Welcome to my video on dividing rational expressions, and you'll notice that I don't have any rational expressions set up right now. It's just 2/3 divided by 4/5. And that's because when we divide a fraction, we're going to be using the exact same technique that we're going to need to start off with all of our division for rational expression problems. And that is, when we divide fractions, 2/3 divided by 4/5, well, we always multiply by the reciprocal. So we keep the first fraction exactly as it was, 2/3. We change the division sign to a multiplication sign. And then we take the reciprocal of the second fraction, flip it upside down, 5/4. And then we can handle it. 2 times 5 is 10, 3 times 4 is 12, and that turns out to be 5/6 when we simplify it. This process, what we just did here, if you are dividing rational expressions, that is the very first thing we're going to need to do. We are going to need to flip that second fraction and make it multiplication. And then it's going to be the exact same steps that we did in the multiplying rational expressions video. So if you haven't watched that video of mine yet, I recommend going back and watching it, and then trying to watch this video and practicing with division. With that said, let's get into the examples. Alright, we've got 4x to the third over 9x squared y divided by 16 over 9y to the fifth. Like I said in the intro, the very first thing is we're going to get rid of this division by keeping the first fraction the same and flipping the second fraction to make this multiplication. So I still have 4x to the third over 9x squared y, but we're changing it to multiplication times 9y to the fifth over 16. Now, if you watched the multiplying video, you'll know that we have multiple ways to start. We can just multiply across, top times top, bottom times bottom, or we can do some cross-canceling to simplify it before we do the multiplication. I'm going to use that second method. I'm going to cancel some stuff out first because, well, I think it'll work out nicely with how this is set up. Notice that I have a 9 here on the bottom, and then I have a 9 on the top, so those can cancel each other out. Notice I have a y on the bottom and a y to the fifth. So I can cancel out my 1 y on the bottom, and I can take away one of the y's on the top. So it becomes y to the fourth. I have a 4 on top, a 16 on the bottom, and both of those can be divided by 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. And then we are almost done. The last thing is these x's. 1 on top, 1 on bottom. I have x to the third up top, x squared below. So I can take away all of the x squareds on the bottom. Now I've canceled everything on the bottom, so that's just going to be replaced by a 1. And then this is going to be x to the first up top. So what do I have left? I have a 1, x, y to the fourth on top, all over 4. And there's our answer. X, y to the fourth, all over 4. Now, let's just play devil's advocate, and let's say that you didn't do it this way. Okay? Let's see how it would look if we had done just the straight multiplying top times top and bottom times bottom. So 4x to the third over 9x squared y times 9y to the fifth over 16. So top times top, that's going to give me 36x cubed y to the fifth over, all right, 9 times 16 is 144. X squared y. And then we'd have to do the simplifying process with this. X to the third over x squared, that gives us a single x. Y to the fifth over y, that gives us y to the fourth. 36 over 144, yeah, that's really 1/4. So it all works out to be exactly the same. It just matters of what your personal preference is. Either way is fine. But there we have it. We have just divided a rational expression. And all we had to do is change it to be multiplication, flip the second fraction, and then do the exact same process that we did for the multiplying rational expressions video. We're going to do one more example. Same idea with division first, changing it to multiplication, and then we'll be good to go. Alright, we have a particularly nasty example here, but if you can handle and understand what we're doing in this example, there's really not too much that can stop you. We have x to the fifth minus 4x cubed over x squared minus x minus 2 divided by x to the fifth minus x to the fourth minus 2x cubed all over x squared minus 1. You most definitely could multiply these top times top, bottom times bottom after we flip it. But this is going to be a prime example for why factoring and canceling out first before we do the final multiplication steps is your best choice. So let's take a look at what we're going to do. We're going to keep this first rational expression by itself, or as itself, I'm not changing it. Change the division and multiplication, flip this. So we've got x to the fifth minus 4x cubed all over x squared minus x minus 2 times x squared minus 1 all over x to the fifth minus x to the fourth minus 2x cubed. We have flipped it, changed it to multiplication, and now the easy part's over. Now we're going to have to cancel out what we can after we've factored all 4 of our pieces. So, buckle up. Let's take this one first. This you might notice as the difference of squares. X squared is a perfect square, 1 is a perfect square, and we are subtracting them. So when you have the difference of squares, remember you can do x plus 1 and x minus 1. That is how we factor the difference of squares. Take the square root of x, it's x. Take the square root of 1, it's 1. And then add and subtract. So that one, we've factored it out. Now, let's take a look at the other top over here. I've got x to the fifth minus 4x cubed. It's a binomial. The greatest common factor between x to the fifth and x cubed is x cubed. So I can take out an x cubed, and it's going to be multiplied by x squared minus 4. Okay? And we're going to have to come back to that because, well, x squared minus 4 is a difference of squares in and of itself. Remember when I said that this is a particularly nasty example? Now we're seeing why. Alright, let's go to this bottom. I've got x to the fifth minus x to the fourth minus 2x cubed. It's not a quadratic, so I can't use the diamond method, but I do have x to the third that I can cancel out of all of those, so I'll factor out an x cubed. And that's going to give me x squared minus x minus 2. And then on the bottom over here, I've got x squared minus x minus 2. Here I do have to do the diamond method. And we would have a negative 2 on top, a negative 1 down below. That's going to be negative 2 times 1. To get those all to work out together, so x minus 2, x plus 1. Now, there's still more that we have to do, but I want you to notice something. I had x squared minus x minus 2, and I just factored it into this. When I took out this x cubed, I had another x squared minus x minus 2. Well, I can factor this and replace it with this as well, so why not do that? I'm going to change that. Save me maybe a little bit of time later on. So this is x minus 2 times x plus 1. Now let's see what we can cancel in its current state. There's going to be more we have to do. But let's see. I have an x to the third up top and an x to the third down below. Let's get rid of them. I have an x plus 1 on top and an x plus 1 on the bottom. Okay, I can get rid of those. And currently, that's all I can cancel because I've got x squared minus 4 and x minus 1 on top, and then I have x minus 2 times x plus 1 times x minus 2 on the bottom. Now, the only thing left that I can do that might help me is factor this out, x squared minus 4. This is another difference of squares, just like x squared minus 1 was. X squared is a perfect square, 4 is a perfect square, and you're subtracting them. So, let's see what this is going to become. If I factor this out, take the square root of x, which is x, take the square root of x squared, which is x, take the square root of 4, which is 2, and then I have plus or minus, and now I'll bring back everything else. X minus 2 times x plus 1 from the left side times x minus 1 over x minus 2 from the left side. And I just got my sides mixed up, sorry. These were from the left side, this was from the right side. So what can I cancel? I have an x minus 2 up top and an x minus 2 on the bottom. Those are gone. I have an x plus 2 and an x minus 2. That's not going to cancel. I have an x minus 1 and an x plus 1. Those aren't going to cancel. So our final answer is going to be x plus 2 times x minus 1 all over x minus 2 times x plus 1. And we are done. Some people say, oh, you can then multiply that back out. Nah, not worth it. You might make a mistake. And with all the work that we've already done, why would we want to risk it? So let's just recap what we did. Let's go back all the way to the beginning. We had this nasty division of rational expressions problem. We started by changing it from division to multiplication, and we flipped the second fraction. Then we started factoring. We factored out the greatest common factors from the top numerator and the bottom denominator. We then factored the top on the right side by using difference of squares. We factored the bottom of the left side using the diamond method, and it just so happened that it matched on here, so we replaced it over there. Then we started canceling. Canceled out what we could. Then we did difference of squares on the top again, brought everything else down, canceled out 2 more pieces, and compiled everything that was left. And we were left with x plus 2 times x minus 1 over x minus 2 times x plus 1. And there we have it. There is division with rational expressions. Not for the faint of heart. It takes a while. There aren't really many shortcuts for these, but they are very good practice. If you have any questions, let me know. Good luck.